Okay, let's think about how to model genetic drift in a population of haploid organisms. So I've already set up a spreadsheet with 500 rows or 500 generations of evolution and 100 replications of the simulation. And here we have our effective population size. What we can think about this as that's not the true population size. The true population size may be 20 or 100 or 1,000, but only 10 of those are contributing to the next generation. So that 10 under drift is going to be a completely random sample of the next generation. And then here's our initial frequency of an allele. We're going to use a single locus, two allele model, and our initial frequency of allele A1 is 10%. One of the 10 individuals have this allele. So we'll get back to what these are in a minute, but let's just set up the simulation. So the first thing is in generation 0, we need to set our initial frequency, and that's going to be equal to this cell. So I put the equal sign and click into that cell to populate cell B13 with the initial frequency. And I want to fill this value across all the way, but I want to keep the column constant. So I need to put a $sign in front of the B to keep that column constant. Now I fill it across all the way to the 100th simulation, and there's our initial frequency at generation 0. All right, now what I want to do is I want to sample from those 10 individuals. And for that, I want to sample from a binomial distribution. And in the binomial distribution, the probability of sampling A1 will be equal to that frequency. And we're going to sample 10 times. All right? So I need to use the Google Sheets built-in binomial sampling function, which looks like this. Binom.inverse. This is the number of trials. This is the number of samples that we create. This is the number of alleles that we sample from the larger population. This is the probability of sampling allele 1, right? And then this is just going to be a uniform random number. So let's go back, and we put binom inverse, and what was it? The number of trials is first. So there's the number of trials. The probability of sampling A1 is, oops, we don't want that. We want that. It's the frequency and the generation that we're sampling from. And then we want to just put in our random number generator there. All right? So we need to make this, will give us a number. If I resample, this is giving the number of alleles that are A1. What we want is to turn that number, that count, into a frequency. So let's go back to it, and we want to divide it by that. Okay, so there we have it. And we want to fill this down, but certain parameters in this function we want to keep constant. So for example, we want to keep B3 constant. That's the number of trials. So we are going to keep the column constant, and we're going to keep the row constant. Column constant and the row constant. Right? What about B13? Do we need to keep those constant? No. As we fill this down, we want the probability to move down with it, because the probability of sampling A1 is not going to be the initial frequency, but the frequency from the generation that we're sampling from, right? So the frequency, that frequency is going to be in the cell above. Okay, so here you see, we see the first problem of running of this simulation, and that if that frequency is 0, we don't get a result. So let's create a function that checks for that and ends the simulation if that is the case. So what I'm going to do is I'm going to go back up to this function, and I'm going to put it if the frequency in the generation before is equal to 0, right? Then we are going to just put a blank there. Otherwise, we'll go ahead and solve it, because now this frequency is not 0, so we'll compute the new frequency. So we can close that up. All right. Now, if I go down, all right, there you can see I have a 0, and there we have a blank, so my new function is behaving correctly. But here we have another error. That is, this is checking if that's a 0, but not if it's a space. We also want it to be, if it's a space, we want it to end the simulation or populate that cell with a space. So let's put that in. If, oops, let's start it at here, the first cell. If B13 equals nothing, we want to put nothing. Otherwise, we want to continue with what we had before. All right, so now let's fill that down, fill it down, and we see, let's see, will this work? Not working there. If, oops, fill that down. There we go. Okay, that's working. Let's fill that across and just kind of look at the behavior and see if everything's working. All right, here we have another error. When the allele rises to fixation, we get another error. We need to end it. Okay, so let's add that contingency to our function. So we want to go back to the very first one, and we want to write if that value equals to 1, then we want to just end it by putting a blank value in. Otherwise, let's just continue to fill it out like we have. All right. Now let's fill that down, fill that across. Do we have any ones? Don't have any ones yet. Let's fill it across some more, fill it across. Let's just go all the way across. All right, there's a 1, ends properly. All right, oops. Here we are. All right, so there's our basic simulation. Now what we want to do is start to compile the results. Actually, let's go all the way down to 500. We may not need to, but I'm going to go down to 500 generations. Maybe for a bigger sample size we'll need it. And now I'm going to fill across. Grab that handle and fill all the way across. So now we should have a properly behaving simulation. We can change these things. For example, I can make this 100. All right. We see we need many more generations at 100. Okay. So now let's put some summaries. The result, 1 equals fixed, and 0 equals extinct. So basically, I'm going to put, let's say, let's use if min of all of this if the minimum value is 0, then it went extinct. Right? If the minimum value equals 0, it's going extinct. So we want to populate that cell with a 0. Otherwise, we want to populate it with a 1. Let's see if that works. Let's move that across. Let's find our 1s. Here's a 1 there. So this goes to fixation. All right. Let's move that back to 10. So we have smaller number of generations. Fixation, fixation, extinct, 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 fixation, fixation. There we go. So there, this will tell us which simulations allele A1 went to fixation. Right? What about the time to fixation? For that, we're just going to count the number of generations. Equals count, and we'll start with generation 1. Right? So we'll go all the way down, and it will only count the cells that are populated with some value. All right? So in one generation, this ended, but this is time to fixation. So we want to limit this to only those simulations in which A1 goes to fixation or in which this value is 1. So we can do this. If the result equals 1, then count the number of generations. Otherwise, put nothing. All right. So generation 1 goes to fixation, and it actually counted it. All right. Very nice. We do, yes, that's good. So let's move that across. All right. Now we can compute some summary statistics for the whole simulation. And for that, let's go to the fixed frequency. What we want to do is we want to just count the number. We want to compute the frequency, the number of what fraction of the simulations did allele A1 go to fixation. So that is just going to be the couple ways we can think about it. We could just sum this row up. That would count all of these 1s, right? And then divide by the number of simulations. Or we can just simplify that by just taking the average over all these values. And there it is, right? And then the median time to fixation is just going to be the median of all of these values. All right. So here we have our initial frequency is 1. The expected number of trials, the expected number of simulations that will go to fixation, A1 will go to fixation, is 0.1, since in a haploid organism, the probability of fixation is equal to that allele's frequency, right? So we can just, let's copy and paste this in. That will redo the whole simulation, and we can see how our actual frequency compares to our expected frequency. All right, so bouncing around, a little lower, a little lower. There it is, a little lower, a little lower, a little higher, a little higher. Okay, If we made many more columns, say 1,000 columns, this number would be near the expected value much of the time, right? Let's put a different frequency in. Initial frequency, something like 0.5. We expect that number to be near 0.5. Right? So you can see it bouncing around 0.5. Finally, let's create a plot of what these trajectories look like. And for that, I'm just going to plot, say, the first 10. So I'm going to copy the first 10 simulations. Insert chart. We certainly don't want this chart. That looks pretty ugly. So we want a line chart. We want the x-axis to be generation, and we want to remove generation from one of the series. And we only want it, Google Sheets isn't very smart about what the x-axis should be, so let's limit the x-axis to just a few generations. So for that, let's hit customization, the horizontal axis, and the minimum will always be 0, and here we can change the maximum. Let's change it to 100, just see what that looks like, right? That looks pretty good. We could change it to 50, right? That looks pretty good. If we rerun it, we see we get a different result. All right, another random result, but what is predictable about the random result is the frequency of fixed A1 alleles, which the expectation is the frequency, the initial frequency that we started the simulation. Right? So something like 0.1 would be an initial mutation with 10 individuals. That mutation will only occur in one of them. All right? Okay. Let's run that a couple times. All right? Each of these we expect 1 out of 10 to go to fixation, and what you're seeing is there's 2 out of 10, there's 1, ooh, there's a lot, interestingly, but you see that over the 100, the fixed frequency is exactly what we expected. All right, that's it.